Okay, hello everyone. Thank you for attending. And so in today's tutorial, I'm going to show you how to create interactive web app using Google Engine, either using JavaScript or Python. And first, let me show you the links. So Jeff already showed you the slides. So here are some of the, including the source code and also the published web app. And so I'm not going to go into detail about each code block. I will show you guys general the workflow and also kind of big picture, because to me this is very important, because especially if you're doing some great work, eventually we want people to use your stuff. Either it's data set or you have some new algorithm, you want people to try it out. So this web app makes it really useful because it makes your resource more reproducible and more accessible. So essentially, people just need a browser. They can go to the URL. They can try out your app easily without having to install anything. They don't even have to have a Google Engine account. So this is one way to make your work more widely accessible. And it's especially important in the future if you're publishing any papers, project report or something like that. You might want to keep this in mind, that how to make your work more accessible. And today I'm going to show you how to do it using JavaScript and also Python. So here there are two, the source code and the web. Before I get into that, I want to show you how to get access to the chapter. So if you go to the book website and then table content, so scroll down to section F6, advanced topic, and then you click, it should open up the Google documents. And so for the chapter I'm going to demonstrate today is F6.3. Shredding works in Earth Engine and also basically the UI and apps. Here are some of the learning outcomes. Essentially, I'm going to show you how to design the user interface and how to publish it. There are different ways you can publish it. If you're using JavaScript, there's pretty much just one way. You can develop the app and deploy using Google Engine. If you're using Python, there are different ways you can do that. So I'm going to show you different examples. And you can read the chapter for more detail. I will not have time to go into the detail, but here are some links. If you want, you can check out the Google Engine official documentation. There's a section here, apps and user interface, show you how to develop the apps and how to deploy step by step. And I will show you some example today. Essentially, if you click the widget, so this is basically the components for the web app. So your app need to have, for example, some drop down list, some button or radio button, something like that. On the right here shows you some of the basically the components of the web app. We not use all of them, but we use some of those in the tutorial today. And also more like the panels, the layout, more like the containers holding those widgets. So this is on the JavaScript side. There's also something on the Python side. Especially mostly we're going to use iPyWidget. It's iPyWidget essentially is like it has a front end and so the back end. So the front end is displayed using JavaScript, and then you can have source code to link between the front end and the back end. So you can have some apps that interact with so the user see on the browser is the front end, but it has Python source code in the back end to execute and run some data processing and then return the result and display on the front end. So similarly, on the right here shows you a kind of widget. So these are all the Python widget, and most of the packages that develop are built on top of this widget. So you're welcome to try it out. It's pretty easy and straightforward to get started. And also the other one is called output widget. So the output widget is also very powerful. It can pretty much display anything, text, figures, images, even video. So and so those are the basics. Here shows you the kind of interface, like ZMap is the package that I created, I think, in April 2020. So roughly 3 years right after the pandemic. And this is the app we are going to show you today, developed using Python. It's going to be on top of ZMap. So we have a couple sections here. The first one to show you is using JavaScript. So this is basically the traditional way of publishing your source code. And if you scroll down here, you should be able to get access to the repo of all the source code for this book. And if you click this one and then accept that, use the ability to find it on your Google Search Engine account. Let me show you here. Once you click and accept, it should come up somewhere here on the left side on your Google Search Engine JavaScript core editor. And for specifically for this chapter is F6, and then F6.3. If you click the first one, F6.3 the checkpoint. So we have all the source code, and this makes it reproducible. So you can just load the source code. It looks quite complicated, but it's essentially pretty simple. Let me run this one here just to show you what it looks like. What we are trying to achieve here today is to show you how to create this kind of app using both Python and also JavaScript. What we want to do is to compare lane covered maps. It doesn't have to be lane covered map. It can be pretty much any satellite imagery or area imagery. So what we want is one on the left side, the other one on the right side, and we want to have a slider so you can slide through. So specifically for this one, we're using the NLCD, the National Lane Cover Database, and it has data from 2001 all the way to 2019. So we have the drop-down list on the left side, another drop-down list on the right side, and then you can select the year, and then you can compare. So this gives you an idea how you can compare different data layers. It can be before an event, after an event, or it can be different time periods. Depends on how you want to do that, and it's very easy. So you see here, right? If I change the drop-down list, for example, from 2001 to 2011, you see here it changed the data layer, and then you can make changes. We also have a legend on the right side here, and pretty simple. And this is something you might have seen on the internet, especially if you have any natural disaster before and after. People might have publish some of this on the internet and give you access how to compare the data layers side by side. So, and this everything can be done using JavaScript and Python. And under the hood, we're going to use Google Search Engine to retrieve all the images, and you can run computation if you want. So this is a pretty simple one. As you can see on the left side here, we have some widgets, right? So we have text. So this is basically a label. It also have a drop-down list. So it's a select widget. And next, I'm going to quickly go through the source code. Of course, you can, you have time, you can read through it, but it's pretty straightforward. So the first one here, we are going to basically filter the imagery by year. So if you give me 2001, I'm going to give you the layer, the image layer for the NLCD. So if you see here, we have the image collection, and then we're going to do the filtering, and then we can select the lane cover band, and then you return this one as the layer. So what it's doing is, like, if I select 2004, you're going to give you the 2004 layer, and then you're going to plot that one on the map. Then we specify a dictionary. So if you give me like a string of year, I'm going to give you the data layer. So this is what is going to put into the drop-down list. Oops. Did I? Oops. Accidentally change something. Let me click again. Run this one. And then we have this one on the left layer and the right layer. So it's the UI. So this is what specifically available for the JavaScript API. It's not available Python. So anything start with the UI, you won't be able to use that in Python. So if you go to the documentation, scroll down, and these are all the UI. So button, chart, checkboxes, state slider, something like that. And specifically for this one is the map, right? So if you UI dot map here, and this is where you have the map on the left, on the map on the right. So essentially what you are seeing, this one is have two maps, and then the two maps are linked together, and then you have drop down list. If you change the drop down list, you're going to change the data layer. Quite simple. Okay. And then, so this is the function basically here, this code block is this one. So when you create this left selector, it's on the left side. So this one basically have the drop down list and also link to the map. And if you can look at the source code in here, so when you select a data layer, I'm going to update the map, and then based on the layer you selected, I'm going to set the value. So basically control the layer and then specify on the left and the right side. After that, we have the legend. So we have the title here. If you scroll down, this is the title, and you have the position. You also have a dictionary. It looks quite complicated, but it's more like the template that you can fill in to change to your own data. Also, if you're using Python, this is much easier. It's just one line of code. In JavaScript, because we don't really have a whole lot of libraries, and so you have to write the source code Of course, you can have a reference repository, but if you want to have a standalone JavaScript, then you have to do it this way. And then if you put the legend, and after that, this is where you actually construct the legend. So the function where you want to put the legend, and also the dictionary, also the title, and essentially, then we add the legend. And after that, we put everything together, and then you just create a map so that it links together. So these are more like an overall workflow. If you are new to the JavaScript or the apps, this might take some time for you to digest. But I'm just showing you the sample code. You're welcome to make adjustments. So the split, this is called split panel map, and then you can go anywhere you like. You can zoom in, you can zoom out, you can pan, and then you can see different data layers to compare to see the changes across different years. Okay, so this is for the JavaScript app, JavaScript. So next, I'm going to show you how you can use Python. So similarly, in the code example here, I show you the source code. So let me click this one. Oh, by the way, I forgot to mention. So after you create, have all the script, and then you have the app, you can publish it. So upper right corner here, if you click the apps, once you click the apps, then you can click the button, new app. So from here, this is where you can give a name. So for example, I can say NLCD demo and select your account. It's basically your project. So I'm going to use my account. You need to have a Google Cloud project. If you have not done so, you need to create one, and then just click next. So here you can choose whether the content of the editor, or you can have the repository script path. You can just click the default one and then next. Also here, if you want to feature this one under your account, you can do that, but you can just keep it as default. Then just click publish. It should only take, I think, a couple minutes. Then you should have the app up and running. I created this one yesterday, so I can show you what it looks like. So if I click this app, and this is what you're going to see. And all you need to do is to just send this link to anyone. I can, let me see, I can put on the chat here. If you want to check it out, yeah, you can. So this is the same thing that I showed you in the code editor, but now it's public accessible. So anyone can go to the link, they can play with the data. So this is something that you might want to do. If you have any journal publication, you have any project report, you want somebody else to access your data. And the data set is hosted on the Google Engine server. So you don't have to have a nice server. It can be, everything is handled by that. And then users don't have to have a Google Engine account. They can still visualize the data. So this makes your resource more accessible and also reproducible. You can add a lot more stuff to do analysis, but for now, it's just a simple visualization. So I can change the data layer. You should reload the data layer. If I change to 2009, sometimes it might be, if too many people are using it, it might be frozen, but usually it is pretty good. So I'm not tested. I've heard people that if you have like hundreds of people accessing the app, sometimes it might not work very well, but it's better than just putting your data in the cloud and nobody actually really using your data. Okay, so this is how you can develop app and deploy using JavaScript. So next, I'm going to show you how you can do that similarly using Python, but the source code is much more simplified. If you click the Python app source code, it will take you to my GitHub repository. So this one shows you the source code. I think in general, in terms of the web apps, Python is much easier to understand. So what you want to do, you might want to, for example, clone this repository to your computer. So I can just click this one, copy, and you can either download this one as a zip file. So you can click the button to download it as a zip file. If you have never used Git, so for me, I will just open the terminal, and then I can just git clone this one to my computer. So git clone, Control V, hit enter. It should clone this one to my computer. And then I can just open using Visual Studio Code. So you have never used Python or Visual Studio Code before, you can check out the book detail for more details. So here, once it's open, then I can show you the So the notebook is under notebooks, NLCD app. So this is basically the source code. So you can see it's actually a JavaScript Jupyter notebook. And what we want to do is to develop your source code using JavaScript Jupyter notebook. And then you can just deploy your Jupyter notebook as a web app. So when people visit your app, it's actually running the Jupyter notebook and then display the map. So here, of course, you need to install the package. Again, the book has more details showing you how to create the content environment and also how to install the packages. So you can see all the details in there. I'm just going to quickly show you how you actually run this one. So I'm going to click this one, select the Python environment, and then I'm going to select, I believe I create a GE content environment. It might take a couple seconds to activate the content environment, and then let me run this one. So hopefully you will be able to see the map, right, like this. So this is the map. Under the hood is using the gmap Python package. You can check out the gmap.org website for more information and create a map. And then, so in this one, we are using the same thing. We're using the NLCD dataset. And then we're going to filter by year. So for example, I'm going to get the 2019, select the lane cover map, and then just add the data layer. So if I run this one, you will see on the map here above, right? So this is the same thing using Python. And so Gmap has a lot of interactive tools allow you to interact. So I can change the opacity. I can change this if you want to. So right now it's only 1 year, but how can we actually create a drop-down list that allow you to change? So if you scroll down to here, I also have some other options. For example, add a legend. This is only 1 line of code. So add legend and then just title built-in. Compared to JavaScript, you have like 30 lines of code, but now it's only 1 line of code. You can add this one. You can also customize. If you have a customized legend, you can do that as well. We don't really need this one. I can delete it. So next, you can specify the number of years you want to show in the drop-down list. So we have starting from 2001 all the way to 2019. And similarly, we have this get NLCD function. Basically, you give me a year and give you an image. And so if you run this one, just a function, then you can use the looping. So in Google Engine, the function is called .map. So the .map function is a very powerful one. It's probably the most powerful function in Google Engine. It allows you to do parallel processing. So if you give me 5 years of data, I can give you loop through the 5 years and then do the processing and give you the result as a collection. So what this one's doing is looping through the years and give you, depends on how many years of length NLCD you have, and then give you an image collection. Once you have the image collection, then we can, for example, let me show you here quickly. We use the function called TS inspector. So TS inspector accept the parameter as an image collection, and then on the left side, on the right side, and that's it. So just 1 line of code. If I come back to the map right now, take a look. So now this is has a drop-down list on the left side, NLCD 2001, and then on the right side you have drop-down list. Similar to what we did earlier using the JavaScript, but I can show you like this. All right, so now it's 2001, but you can change the data layer. For example, 2011, it should change. All right. Of course, you can also change the layer on the right. It's up to you what you want to do. But the app is essentially the same. So this is using Python, the drop-down list, and also the different data layer. Once you have the notebook, then you can publish this one on the web so that user can access this one. And there are 2 ways you can do that. The first way is to use your computer as a server, or you can have a server somewhere in the cloud. And if I go back to the book chapter here, show you 2 different ways. The first one is using your local computer as a server. So it's a local server. And this one specifically, we are going to use the package called ngrok. So let me show you here. If I click this one, it's going to take you to the website. This one is free, although it has a paid version. But if you can just click the download button, and then from here, yeah, you can download this one to the computer. Depends on your operating system. I'm using Linux. So I'm going to click this one, download, and then save this one to a computer. If you see, this is basically just executable. And I can just unzip it. Here, you will see this one, ngrok. So it's just the exe. the easiest way, if you want to make your, for example, your notebook, allow other people to access that, you can just use this envelope. So let me copy this one, and then I can move it to the notebooks directly here. I paste it here. I might be moving very fast, but you can rewatch the video later. I'm just going to save some time. So once you have the exe here, then I can just show you how you can actually run this one. Again, all the detail in the book, I'm just showing you the general step. So here, right, get into the Angular folder and then activate the contact environment. Then you can spin up the notebook using Voila. So Voila is a Python package that can turn your Jupyter notebook into a web app. So let me show you how we do that, right? So in here, we have the notebook. Then I can just contact activate GE. Within the GE, we already installed Gmap and the Voila package. So I can just type Voila and there's no browser and then the notebook. So if you see the instruction like this, hit enter. Once you hit this one, now your computer is running the web that's serving this specific app. So basically, it's running your notebook, basically executing a notebook and then display the results. So see in here, right now I'm running this one on my local computer, localhost 8866. So this is basically the port number. If you see this one, right, exactly the same thing, just like the notebook that I run in Visual Studio Code. So basically, it's just render the result. And so in that way, people don't see your source code. Of course, you can display the source code if you want. But for this one right now, it's just showing you the output. And again, you can change the data layers. It should change. So this shows you how to display that. But right now, this app right now is only accessible locally. So how do you make your app actually accessible to people outside your network? So for example, right now I'm inside the university, we have firewalls. So people actually cannot access anything from your computer. And this is where we use the ngrok. So basically it's an exe that allows basically expose the server, your server to the public. Usually we don't recommend, but if you want to really, for example, if you're teaching in the classroom or in a workshop, and then you create some app that you want other people to access it directly without having to set up all the server, this might be the way to go. So it's basically just one line of code, then you can make your app accessible. So let me quickly show you how I do that. So right now the app is running. So it's using Voila, and the next step is to showing you this, is to start the ngrok server. So what this one is doing, basically, you can think about this is kind of somewhere in the middleman. And when people visiting this URL from ngrok, and then it's redirecting the widget to request to your local computer. So in that way, you can make it accessible to the public. So what I'm going to do here is doing the same thing. I'm going to run point ngrok and then HTTP 8866. So if I run this one, take a look. So now it's going to show you I'm using the free plan. You can sign up for an account and follow instructions. So now if I click this one, so see this here, forwarding. So this is the URL to the server, and this one is public accessible. This one is only locally. So if I click this one and run it, it's going to take some time because it's actually forwarding the traffic. So right now, this URL is accessible to anyone. Let me see here. Yeah, it should take a couple minutes. Not couple minutes. I think it should be maybe a couple seconds. I tried it yesterday. It actually works, but let me see here. Sometimes it depends on the server. We'll come back later. So this is essentially how you can turn your computer as a server and then make it accessible to other people. So if you're running a website, running some data, something you want people to access it, and this one thing can do. Let me refresh it. It's not working right now, but it should. Let me see here. Anyway, we'll come back later, see if it loads up. It usually should not take this long, and maybe something as well. So let me Control C, display, disable it, and then let me try it again. Oops. Anyway, let's come back later. So this is one way you can easily turn your computer into a server. And the next one to show you actually is the recommended way that you have your app published somewhere in the cloud, so people access the cloud rather than using your computer as a server. It's better, it's more secure, and it's more permanent. So in that way, you don't have to have your computer up and running all the time. It's more like somebody is having a server and they manage it, everything for you. So what we are going to do here is using the Python. So let me show you here. If you go to the GitHub repository, and if you click the repo, go to the home page. So here I'm going to show you how you can deploy this web app using Hugging Face. So Hugging Face is free. You can deploy all kinds of apps, and if you want, you can click this link here, the web app. It's open up and takes you. So look at this one. So right now, so earlier we only run the notebook on a local computer, but right now, this one right now is in the cloud. So if you want, you can, let me send the link. You can try it out. It's actually, so right now this one is running on Hugging Face, and the app that I deploy is here. I will show you later, but right now I'm just going to show you Click, for example. If you open this one, it's similar to we run the notebook on a local computer, but right now this one is in the cloud. So you'll be able to see the app exactly the same thing that I showed you earlier, deploy on our local computer. And you can use the slider, you can change if you want to. So right now this is on a server. So this is the recommended way of publishing your Google Sending app, or it can be any app. It doesn't have to be Google Sending. You can use other apps if you want. So for example, I can use I'm not sure if this one works. For example, Mapbox, right? So you can see here. Oops. So you can basically think about if you have a Jupyter notebook, you have some results, you have some maps, you have some figures. You want user to be able to access that without having to install anything on computer. This is the way to go. So for example, BQ plot, and here, right, I can zoom in, I can zoom out. It's all interactive. So user don't have to see the source code. They will just see the output, and the output come from the notebook. If you want, you can, again, let me open this one just to show you all the notebook examples in here. So if I click this one, BQ plot, take a look at this. So the interactive chart that you see earlier is coming to the notebook. So this makes it really easy because you can just write your notebook, and then once you are done, you just deploy the notebook to the web, and then people can access that just using a browser. And next, let me quickly show you how you can actually create this. So I previously in the book chapter is using Heroku, and when I was writing this chapter, it's free, but Heroku stopped providing its free version. Of course, all the workflow still works, but you just have to, right now, it's not free anymore. So that's why I kind of switched to Hugging Face. But you can follow the same step. The workflow is pretty much similar. And let me come back to here. Right now, if you want to deploy the app, how you can do that. So what you can do is to go to this repo and then click this one, Hugging Face. So the second link, if I click it, it's going to take you to this Hugging Face website. And first, you need to sign up for an account. So it's free. You can just sign up an account using your GitHub or your email. And then what you can do is to click this one here. You can just duplicate this space. So this is very nice because just one click, you can copy all the stuff to your account, and then it turn into a web app pretty easily. You can also start from scratch, but I would not recommend because you have to pay attention here, the README file. This is the port number. So if you remember earlier, when I showed you on a local computer, it's using the port number 8866. You need to change that. So the easy way is just to just duplicate this space, put into the account, and then you should be able to, let me see here, void geospatial. If you go to homepage, it will show like this, refuse to connect. It looks like something is wrong, but it actually is not. So if I go to this one and then embed this space, then if I click this one, it will take this one. So essentially, what this one is doing is that is going to create here we have a Docker file. So the Docker file basically is installing all the packages and then copy the notebook and then just spin up. So this is pretty much similar to what we did earlier with our local computer. We like voila and then no browser and then spin up. Is because in the cloud, this is running basically a Linux machine. So it's running this command and then opening up the app, and then so Hugging Face can render this one. So when user go to the URL, you should be able to see the web app. So this is more like a better way of deploying your Earth Engine web app. So just duplicate the space, and then you can just add a notebook to your repo, right? So once it's duplicated on your account, and from here you click in notebooks, up right corner here, just upload file. So you can just upload whatever notebook you want to render on the app. Once it's uploaded, it's going to take some time to rebuild, and after that you should be able to see the web app somewhere here. So if you add a notebook, you will have this one. If you, for example, have any other apps, you should be able to open and do that. So this is kind of the way that I actually created this repo, I think probably 2 weeks ago, because Heroku no longer provides the free version, but this is the one that I found is works seamlessly and it's much easier. One thing I want to mention is that you do need to set your, if you're using Google Search Engine, you need to set your Google Search Engine credentials. So what you need to do is to come here and then create new secret, and the name is called Earth Engine token. So this is the one that Gmap use. So I'm gonna click here, Earth Engine token, and then you want to go to your computer, under your computer, and then you go to I think your user config, and then Earth Engine credentials. I'm not going to open it because it's basically my password and everything to the Google Search Engine account. So what you need to do is to just double click, open this one, and select all the content. Okay, all the content, not just the Earth Engine token, all the content within this file, and then come here, Control V, then up add secret. Then so when user open the Jupyter Notebook, open your web app, it will use your credentials. So this, if you don't do this one, your Google Search Engine app would not work, because your app cannot allow the user to actually enter their credentials. So it's using your basic account information. And this is one thing that sometimes people run into issues, that you cannot authenticate Google Search Engine. Okay, so this is how you deploy the app using Hugging Face and using Voila. And let me come back to this one. Oops. It's still not working. I'm not sure why. Let me see here. Anyway, so you can try it out, this one on your computer. It should work. Basically, right now, the computer cannot connect to my local, but if I try this one, it should work. And you will see here, it's actually executing because I have 12 code blocks. So it's executing all the code blocks and then trying to render. So it's better to, if you have some very computational intensive steps, you don't want to load it at the beginning. So you have the user interface and then allow user to interact and then do the computation, because when you load up the app, you want to be very, very fast. So this is how you deploy apps using develop using Jupyter Notebook, and then just transform the notebook from a notebook to a web app. And you don't really need to make any changes, so it's pretty easy. You just need to have a server to actually host the notebooks. And the next one I will show you is a little bit better, but it needs a little bit more time to actually put things together. So if you go to similarly my Hugging Face, and there's another one here called Solara Geospatial. So this is a new one. I think I just created probably 2 weeks ago. And so this one is a lot better, but you need to spend some time to actually modify the source code to be able to use that. So if you click in, you should be able to see, like, this is a render using, let me send you the link here. Oops. So I'm going to copy the URL. You can try it out if you want to. So this one is render. It's using the Python package called Solara. So it's allows you to run to develop app using Python or Jupyter Notebook, and then you can render in the web. It's much faster than Voila, because Voila basically you are every time people connect to your server, it's going to spin up a new kernel, and it takes a lot of resources and it's much slower. This one is a whole lot faster. So if you want to see what it looks like, the source code under the hood is in here. Again, you can do something very similar. You can duplicate this one to your account and then just add your Google Engine credentials to the secrets. Then it's done. Then you can deploy the app. So here I can show you the pages, right? For example, in the Gmap, and this is I'm going to show you later, but this is using a package. We don't have time to go into detail how to do that, but it's pretty simple. So here I can create a map and then I can just add some data. So you can add things directly under here. It's not that complicated. So here we just add some data layers, feature collection, and then how to visualize that and add the data layer. So this is pretty much the same like how you use Gmap. And so when you create a map, everything is preloaded and then user will be able to see that. So let me show you how you can actually access the app. So I'm going to go to the three dots and then embed this space and then click this one. So again, this is how it's rendered. So similar to Voila that I showed you earlier, right now this is the website, and people can just go to your website, and if I click, for example, Google Engine, now you see, it's not like using Voila, like executing, it's pretty instant. And the nice thing about this is that you have all the interactive widgets. For example, you can use pretty much anything that you use with Gmap. So here, right, I have different data layers. I can turn the data layer on and off. Right? I can change the opacity. And similarly, I can change the opacity as well. Also, if I click your mouse on the map, you can see I also have the inspector. So this is kind of similar to the JavaScript, but this is actually using Python. So I can click your mouse on the map. It's going to query all the pixel values. You can also have, for example, lane set multispectral. So if I click on the map, right? So now you can see B1, B2, B3. Also, you can source data, you can source location, you can full screen if you want to, and also have all the widgets. So essentially, everything that Google Engine Gmap supports, now you can also use that directly on the web. So it's very nice, very nice. So this is the new way of developing web apps, not just for Google Engine. You can do that for other mapping libraries. For example, I have Leaf Map. I can also use all the things like what I showed you earlier. You can also use Macbox. It's still work in progress. It's not finished yet, but right now it's not full screen. But if I resize, it should work. Oops. Let me see here. We have the sidebar. Let me move it up. All right, so you see, this is using Mapbox or even CGM. Mapbox and CGM, you need to have a token, otherwise you cannot use it. But you can do 3D. So in the past, you will need to know JavaScript to be able to develop apps. But now you can pretty much do everything in Python, pretty easy. So again, let me resize it, and then it should. I have to fix this issue. I haven't set time to do it yet. And also open layer, IPy widget. Also, keep in mind, everything is bidirectional. So what I mean is that you can interact with the map and then you can send back the result. Traditionally, if you're using Streamlit or others packages, it's basically one way. So once the map is displayed, it's done. You cannot get anything out. But this one is different. So if I click my mouse on the map, it get your coordinates. It send the coordinates back to Google Engine, get the result and display it back. You can do a lot of things. So it just open a lot of possibilities that was not possible in the past. So thanks to the Solara package, it's fantastic. So I really recommend that you try it out. And also, once you create an app, you can deploy using Hugging Face. It's free. So just one click, and then you can add your web apps. Again, you can look at the source code. It's not that complicated. So for example, Mapbox, look at this. Only couple lines of code. So most of the code is basically just a placeholder. Essentially, what it's doing is basically using them, for example, the map widget packages, create a map and specify zoom level, center, something like that. If you want to have any specific thing loaded to the map, because by default, it's just a default map. But if you want to preload data, you want to add something so that user can see the data layer, then you look at this example. So here, right, I have the map and then I can preload all the data layer. I also add the layer manager, add the inspector, something like that. You can just customize this, and everything else here pretty much you can keep it as it is. There's not many things you need to change. So it's more like just a template. Hopefully in the future when I have time I can show you more apps, but this is the new way of creating interactive web app solely using Python. So for me it's much straightforward. It's easy, and you can integrate because you can not just using Python. So this is a Python script, but you can also use Jupyter Notebook. You can also run the Jupyter Notebook. And the nice thing, if I click this one here, if you go to, for example, the web app, people probably hard to tell that, oh, this is actually using Python. It's really fast. So if you click, right, see here, it's not like voila, that you click and then it's executing code, blah, 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 blah. It's pretty much instant. So you use less resources, and it's much faster, and it's more customizable. So now for those users that are not used to JavaScript web design, then Python is the way to go. So I have been enjoying this and trying to have more time to look into this. So to have more example how you can interact with the map. So you have all kind of components on the map, and then user can type interact. In that way, you don't have to have lengthy instruction telling user how to reproduce this, because you already provide the app that allow user to interact. It's already reproducible and it's already accessible. Okay, thank you very much. I think I used too much time than what I expected, but hopefully give you some concrete examples how you can turn your work into something this everyone can access, and you can have all kind of free cloud platforms that you can deploy, and then you can also integrate with GitHub. So what I usually do is I have some GitHub repository, for example, hosted on GitHub like this one here, and then so all I need to do is just to add notebook to GitHub. I also have a GitHub workflow automatically push the changes to Hugging Face. So in that way, I don't have to manage two platforms. I just solely based, I tested everything on my local computer. Once it works out, I push to GitHub, and then GitHub take care of the rest. So for example, I just added this one yesterday. So here, right, I just add this one NLCD app to GitHub, and then just sync the changes to Hugging Face, and I'm done. I don't have to manage it. So I would recommend to you to utilize these free resources to make your resource more accessible, and more reproducible. Thank you very much, and I will take any questions that you may have.